Hello, everybody. Happy Friday. Uh, just starting the webinar now. We'll wait just a minute or two here for folks to join, and then we'll get started on our part three of the Big Three Apple Insects webinar series. My name's Josie Dillon. I'm the statewide fruit outreach specialist, and it looks like just a few more folks are joining here. We'll give it another 30 seconds to a minute before we get started. Let folks get settled in. It's absolutely beautiful out. I hope you're all enjoying gardening this summer. I know I am. Um, we definitely needed this recent rain, but maybe not the heavy storms. So hopefully you all fared okay with these storms this week. I know it caused some down trees and whatnot, but all right, we're a minute after noon, so I'm going to go ahead and get started. So again, welcome to the part three of our Big Three Apple Insect webinar series. This webinar will be about Apple Maggot, the final kind of major insect of apples that's just starting to emerge right around now or in the next week or two. And again, my name's Josie Dillon. I'm the statewide fruit outreach specialist and super happy that you all could join today. So I'll cover the agenda here, very similar to the last two webinar parts of the webinar. We'll talk a little bit about the historical background of apple maggots, jump into the life cycle. I'll show some photos of some signs and symptoms and general identification of apple maggot. Then we'll jump into monitoring using trapping and just visual observations. Then we'll jump into some control measures. And then again, at the very end, I have some resources for folks. And I will share this PowerPoint PDF out with everyone who registered. So yeah, like I was saying, this is our final webinar of this series. All these webinars can be viewed through this QR code. There's a link to the recording. Otherwise, if you go to our UW-Madison Extension YouTube channel, the past two recordings are up and can be viewed, and this one will be posted in the next week or two. In my next follow-up email, I'll also be including a code or a link to a evaluation for this series and would greatly appreciate if you could fill that out. It helps me kind of direct my programming and what people are looking for, and kind of what modalities they're looking for. So hopefully you found this series useful and looking forward to what we can do in the future. All right, so a little bit of background, I guess really quick before I jump into this. If you do have questions, feel free, throughout the presentation to throw them in the little Q&A chat. That just helps us keep track of the questions that are asked. And then if there are any remaining questions at the end, we can answer those and send that out with the follow-up email. All right, so jumping into it. So some background information on Apple Maggot. So they are native to Eastern North America, first reported as a pest of apple in the 1860s. They were reported a little bit earlier than that of their kind of native wild host, hawthorn, but first saw major impacts in apple around 1860s. There are two quote unquote races of apple maggot. One is primarily has a host plant of hawthorn. The other primarily has a host plant of apple. And really interesting, this could be a possible case of speciation or the separation of two new species from one original species. There's still a lot of research kind of going into that, looking into like um, genetics and whatnot. So pretty cool, pretty interesting. So kind of a double-edged sword there. Impact to fruit. Apple maggots primarily feed on apple, but will also impact pear, apricot, peaches, cherries, crab apples, wild rose hips. And again, their natural host plant is hawthorn. And the reason why this insect is part of this series, just like plum curculio and codling moth, the larvae it's themselves feed internally on the fruit. And instead of feeding kind of in the core or the seed area, apple maggots actually feed on the flesh inside. They kind of absorb the juice as they make their way through the apple. So apple maggot is in the order Diptera, so they're a fly in the family Tephrididae. Um, like I said, they feed internally on fruit, on the flesh. They used to be kind of nicknamed railroad worm because they leave these little tracks through the apple if you cut it open, which I'll show in a couple slides here. Just one way, if you are cutting open fruit, any fruit this summer, and you're like, I wonder which one this is. If you see any, dark paths through the flesh of the apple, that's pretty indicative of apple maggot. And once the larvae are inside the fruit, it is really hard to control them. If you really think about it, they have a huge barrier around them and they're really protected in there. So a lot of times we're targeting the adult flies when we're using management practices. And the apple maggot themselves, they're mostly black with a white triangular dot on the thorax. You can see in this lower photo here on the right-hand side. And some differentiation between males and females. The males themselves have the 3 white stripes on their abdomen, while females have 4 white stripes. And they also have this F-shaped pattern on their wings. So that's one way you can kind of determine if this is an apple maggot. I will talk about some similar species that can be sometimes difficult to differentiate, but for the most part, if you are capturing any flies with, these black and white flies with this F-shaped pattern, this dot on their thorax and stripes on their abdomen, that's most likely going to be apple maggot. So their life cycle, apple maggot overwinters as pupa, so in the top 2 inches of the soil. Something interesting though about apple maggot is sometimes that pupa will actually stay in the ground for an additional year and will emerge the following year. There's still a lot of research going into why this happens. A lot of times it has to do with temperatures, kind of over the winter and the spring, different soil moisture, as well as soil type kind of plays a role in that as well. The pupae that do overwinter and emerge as adult flies the following year will usually emerge in early summer, usually around mid to late June. And once those adult flies emerge, the females will um, kind of fly around for about 8 to 10 days, and then they'll mate and they'll go around and lay a single egg just under the skin of the fruit. And usually adult females will live for about 30 days or so and can lay up to 300 eggs over her lifespan. So while she's just laying a single egg at a time, 300 eggs for a single adult female is quite a bit. And so if you can imagine, this can be a pretty devastating insect because once an apple is infested, it's usually sometimes will rot out or drop from the tree and usually isn't very appealing and generally inedible. So the goal here is to prevent the adult females from even laying an egg in the fruit itself. Once that egg is laid, the larvae will hatch and it goes through 3 developmental stages. Usually in that last stage, it's done enough damage, and that's when the fruit will drop from the tree. And then once that fruit is on the ground, it's a lot easier for that larvae to emerge from the fruit and then pupate in the soil. So as promised, here's some of that injury, kind of what it looks like. It's usually, sometimes it can be a little sneaky, and a lot of times you might not even be able to tell an apple is infected or infested with apple maggot until you cut it open. So here on the left-hand side, you can see these dark kind of dimples, spots on the outside of the apple, and that is oftentimes apple maggot, but can also has really similar symptoms to some summer diseases. So a lot of times, if people are concerned or have a hinkling that maybe this is apple maggot, it might be worthwhile just picking that fruit, cutting it open, and seeing if you can see one of the larvae inside. If you don't see a larvae, it's most likely a disease of some sort. Um, and like I said, apple maggots, at least adults, are active from mid to late June and usually through about harvest time around September. And in the right-hand photo here, you can see again more of that dimpling, kind of lumpy fruit appearance. And that's just some deformities that happen as that apple's developing, and as the larvae kind of destroy some cells as they're feeding. And here on either side of this lumpy fruit, you can kind of see these dark brown trails. That's very indicative of apple maggot. And again, that's kind of why their nickname is railroad worm. So they kind of just leave these tracks through the apple, usually starting from the outside, penetrating to the middle, um, as they kind of make their way eating on the flesh of the fruit. All right, so we just talked a little bit about identification, what the insects look like, or the adults look like, what the larvae look like, what that damage or fruit symptoms might look like. Now we'll kind of jump into some prevention. So talking a little bit about horticultural practices, some detection, covering monitoring and trapping, and then at the very end, talk a little bit about physical and biological and chemical control. So this is called the IPM triangle, and it's essentially just a tool, a decision-making tool that people can use to limit impacts on the environment. And our goal here is we're trying to do the best we can to limit our chemical control inputs. We really want that to be kind of our last option, last resort if none of these other methods are working. So I like to share this slide just to kind of highlight the IPM triangle, talk through some of these steps to take when looking to control this insect and a lot of other insects as well. All right, so those of you who have joined the previous two webinars, this probably looks very familiar to you. I usually like to just kind of pound it home that this is really important to, do some record keeping, do some scouting so that you know what's happening in your trees. And you can kind of look back at that from year to year and help, which helps to make decisions. So I always say you don't know what you don't know. It's great to get out there, kind of take a look at your fruit, take a look at the health of your trees, just kind of get an idea of what's going on. And during the summertime, ideally, we're getting out there every week to take a look at our fruit, at our trees. This is because, insects, diseases, those can kind of spread pretty rapidly, especially during warm, wet conditions, and especially when we have really warm temperatures at night. So some record keeping tools that, kind of go with what works for you. I think that's kind of realistic. So some record keeping tools available out there. There's, classic Excel or Google Sheets, just using your phone, a tablet, or maybe you're taking a look, coming back inside and typing it into your computer, just keeping notes of what you're seeing and when you're seeing it. There are also some downloadable templates. So this one is from Penn State University. Just kind of has a list of insects that you might observe and some spots where you can just kind of plug numbers in. It's really nice and easy, so you don't have to create your own. But totally understandable if you do want to create your own. I know sometimes that's how my brain works. So then there's the classic phone notes app, just going out there, taking some notes on your phone as you're walking around. And then my personal favorite is pen and paper. I think sometimes that helps me remember things a little bit better when I physically write it down. And it's just a little more fun sometimes. So yeah, just any of these tools it's really, really good to keep track of what you're seeing and when you're seeing it. So it can help you make decisions later on. Some things to consider when you're out there looking at your trees, looking at your fruit, is to write down the date. So we know kind of what time of year you're seeing some of these symptoms. If you can identify it, writing down the pests that you're observing. is important so that we know kind of what options are available for that specific pest. Ideally, you'd get the location on the tree. So maybe it's on the fruit, maybe it's on the leaves, maybe it's on the trunk or the branches. Just kind of trying to get a good idea of where you're seeing those symptoms or that injury. If possible, including a description of the damage or symptoms. So if you're seeing any wounds in fruit, if you're seeing any, discoloration of leaves, just kind of giving a little bit of a description of those damage symptoms. And finally, photos are worth 1,000 words, right? Oftentimes, especially if we're asking for help with identification, including photos can be really helpful. Sometimes, if you think about it, our short-term memory, sometimes we miss a few details when we're trying to recall it. So photos are definitely helpful, and I usually always recommend folks to try to take some photos of what they're seeing. And if you do need help, we have a really, really awesome tool called Ask a Gardening Question. At UW-Madison Extension. And there's a form that you can fill out that includes kind of all of these things here. You can plug in the date, what you observed or what you think you observed, where you're seeing it, kind of a description of those damage and symptoms, and then there's an option to include photos to upload as well. So yeah, if you ever have any questions or aren't able to identify or have questions about what you're seeing, this is a really, really great tool for folks in Wisconsin to use. Some other options. So outside of ask a gardening question, if you're just kind of taking a photo or just curious about what you're seeing, um, there are some really great tools out there for help with identification of pests and diseases. So there are a few apps like Seek and iNaturalist. That's where you just upload a photo and it kind of gives you a best estimate for what species it thinks it is. And then there's also a really cool part of this where it's kind of community based and people can come on and either agree with you or disagree with you and recommend another ID. So really cool. I use iNaturalist a lot. It's just fun and it's cool to have like a list of your life list, right? Of what you've observed in your lifetime or in the last several years. There are also books like field guides that have really great photos and descriptions. There's always new ones coming out, so it may be worthwhile to kind of re-up some if you have some older ones. I know our team is working on a vegetable insect identification guide right now, which I'm very excited for. And in the future, we're hoping to do a fruit field guide. So keep your eye out for that in the next year or so. There's also websites like Bugwood. That's kind of the classic insect identification website that a lot of entomologists use. They can kind of compare photos. It gives a really good description of their, life cycle, their natural habitats, and range in general. So sometimes we might think it's a certain insect, but then you go and look and you're like, oh, that's only found in Europe. Or, oh, okay, well, this is only found in South America. So it's a good way to kind of rule out some options. And then finally, there's, ask an expert. Your arborist or local extension specialist can be a really great option. And then, of course, that other tool, Ask a Gardening Question, is also really excellent. All right, so once we kind of are able to identify that insect or disease pest, the next thing we want to jump into is monitoring for it. So really getting to know when that insect pest is emerging, how impactful it is, and kind of when you see it tapering off a little bit. So I included this table here. This is from one of our publications. I circled the big three insects, right? These are all the ones that feed on fruit directly and are the most damaging in the apple world. So in the very top here, I circled Apple Maggot, and you can see there's monitoring for adults, monitoring for larvae or damage, that's the pink, and then control periods is that kind of dark color on the bottom. So here we see, late June into early July, we really want to be monitoring or starting to monitor for those adult insects as they're emerging from the soil, from overwintering as pupae. And then um, the pink here is when we want to monitor larvae or damage. So most of the time with these insects, we're really looking at damage. We're not really going to see the larvae unless you cut that fruit open. But that happens about 2 weeks after initial adult emergence. That just takes a little bit of time for that egg to develop and hatch. And then finally, there are our control periods. So we'll get a little bit more into this with trapping, talk a little bit more also about degree days and kind of how we can estimate when that emergence is or identify when that emergence is as well. All right, so trapping is a very important tool and useful tool, especially with Apple Maggot. And I'm happy to say that that trapping is also very useful in home orchards where maybe we have a tree, two trees, 5, 10 trees. So the previous two insects I talked about, a lot of the trapping was really specific for at least an acre of trees. But with apple maggot trapping, it can be successful with just a few trees as well. So there's a few different traps that folks can use. There's the yellow sticky trap, and that's usually hung, right in the early kind of emergence period. And the reason for that is because if you remember from a couple slides ago, initially after emergence, they take about 8 to 10 days before they even start laying eggs. They just kind of need to mate, of course, and then it just takes time for that egg to develop and for that egg to be ready to be laid. So about 8 to 10 days after emergence is when they'll actually start laying that egg in the very underlayer of the skin of the fruit. And then there's also red sphere traps. So this will be what the majority of people use. A lot of the growers I work with mostly use these red ball traps. They just kind of get them hung early and are able to monitor them kind of throughout the summer. And the key here with these traps is you can use baited or unbaited traps. So baited traps, that's essentially for the red sphere trap. We're really just using, it's called an apple essence lure. So it smells a lot like apples. And we use the red sphere trap specifically because they look a lot like apples. And the adult females are actually attracted to that red color and the scent of ripe apples, right? The larvae just have a better chance of survival if the apple is a little bit further along, because as that apple grows and expands, the pressure inside might increase and it might end up killing the larvae. So they usually try to go for, those red apples. It's visually appealing to them. So that's why we use these red spheres. And the baited traps have that apple essence. Otherwise, a lot of folks just do unbaited and have success with that. I'll talk about some of the key differences in terms of threshold in a couple slides here. And the reason why, these work is because both are coated in this sticky substance. And the yellow sticky traps usually come pre-coated, which is kind of nice, but lose effectiveness as the females begin laying eggs. They're not quite as attracted to that yellow color. They're more attracted to that red color. So what a lot of people do, and there's a lot of different types of red ball traps. I've seen people make their own just out of wood or cardboard. They just paint it red, use some string to hang it in their tree. There are some disposable traps that you can purchase. And then these are kind of more, this one itself is pretty hard, like plastic that can be used from year to year to year. So a little bit more durable. The key here with the baited versus unbaited is that threshold for baited traps is 1 fly captured, while unbaited traps is 5 flies or I'm sorry, flipped. I flipped those around. One fly for unbaited and five flies for baited. And that just means the population is high enough that probably warrants treatment of some kind or management of some kind. If you are using these traps or you want to use those traps, you can hang them really anytime. Especially if you're in southern Wisconsin, we're a little bit more ahead in terms of weather, temperatures, and development. So it'd be a good idea to hang those in the next week or two. If you're up in northern Wisconsin, it might be okay to wait a week or two before you put these up. But I always say it doesn't hurt to put them up early. We're seeing a lot of shifts in emergence. Sometimes they're emerging a little earlier. I've had a grower down here in southern Wisconsin who actually had her first trap capture about a week ago. So they are definitely kind of shifting their emergence to earlier as we have warmer springs. The key with these traps is to hang them around eye level and especially around border rows. A lot of times, the larvae will pupate kind of on the edges of the in orchards, usually kind of in that hedgerow or along the edges, so that they can come in from the perimeter. And if you are interested in trapping, um, it's ideal to hang them in the earliest maturing varieties, so ones that will be turning color earlier, or trees closest to like that border row, or if you have an abandoned orchard nearby, which I'm finding is very common here in Wisconsin, and is oftentimes those abandoned orchards can harbor insects, and then that kind of feeds into nearby trees or nearby orchards. So hanging those around the edge rows or kind of the perimeter of your trees if you have a couple rows. Otherwise, if you just have a few trees, kind of hanging them around the outside of the tree is just fine. So I mentioned lookalikes earlier, so I just wanted to show this comparison. If you do have any blueberries nearby, it may be worthwhile to kind of familiarize yourself with some of the key differences between these two species. As you can tell, upon first glance, it can be really hard to differentiate between blueberry maggot and apple maggot. So blueberry maggot's on the left, apple maggot is on the right. They have really similar color patterns with that white dot in the middle, the 3 to 4 lines on the abdomen, and that F-shaped wing. So sometimes folks who maybe aren't sure will even send those into our insect diagnostic lab for identification. I also wanted to throw in a just a photo of what this apple essence lure looks like. You can just kind of slip that onto a branch nearby the trap you're hanging, or just slip it onto the string or the wire you're using to hang the trap. And those can just stay on there as through the summer. And you can order some of these disposable traps or some of the kind of long-term, more hardy traps from Great Lakes IPM. They're pretty cheap. I can't recall off the top of my head how much they are, but it's a really great resource for them. And then I also threw in this slide a little graph showing the green apple maggot adult emergence versus the purple blueberry maggot adult emergence. And this was from a study done in Southwest Michigan. So you can see sometimes blueberry maggot emerges a little bit earlier than apple maggot. So once in a while, if you are getting some of those earlier trap captures, it might be worthwhile to try to identify it and make sure it really is apple maggot, especially if you have blueberries nearby. But for the most part, if you have just apple trees and no other kind of fruit nearby, it's almost always going to be apple maggot. All right, so talked a little bit about trapping. Degree days for apple maggot is more supplemental rather than using it for making decisions. So it's more so you can have a better idea of when things might be emerging and whatnot. So just a reminder here, I'm kind of going through this in each talk, just because I know sometimes it can take a few times to really have it sit with you and be able to fully grasp. So just three key terms here for degree day models. Biofix, that is when sometimes it's a biological indicator, sometimes it's just a calendar date. There are a lot of models that use January 1st as a start date for counting degree days. So it's used to that biofix date is when you will start counting your degree days. Another two key terms here for degree day models is your base temperature and your max temperature. So in a lot of these models, they have the lowest temperature, your base temperature, and any temperatures that drop below that, degree days are not accumulated. It's just too cold for that insect to actually be developing. And yeah, so max temperature is the opposite. It's the highest temperature where insect development rate peaks and does not increase. So for Apple Maggot, that base temperature is going to be 50 degrees Fahrenheit. And the max temperature is somewhere between 85 and 88 degrees Fahrenheit. So I threw in an example calculation here. And again, just to reiterate, insects do develop based on temperature. So the colder it is, the slower they develop. And the warmer it is, the faster they develop. So that's why these degree day models can be really useful, so that we're really hyper-focused on the current weather patterns and how that might impact development of a lot of insects. But this is just a really general calculation. So here we have daily degree day, base 50 for that base temperature. And we're taking our average daily temperature minus that base temperature. So your average daily temp can be really easily calculated using like a weather app. You just look at your high and low for the day, add them up, divide by 2, and that's your average temperature. And then you just subtract 50 in this case, or for a lot of insects, it's 50, but just make sure if you are using this, don't generalize 50. Sometimes they're different for different insects. So here is an example. Let's say the average temperature was 55 degrees one day. So again, we're taking that average daily temperature minus that base temperature. So 55 degrees for that average minus the 50 degrees base temperature equals 5 degree days for that single day. And then you do this calculation every day until you've hit kind of the threshold for when that insect is emerging, when eggs are hatching, etc. So the Apple Maggot degree day model, again, it's not typically used for management decisions, but is more informative, just so you can have a general idea of when, like best guess, best estimate for when they might be emerging. The key here with Apple Maggot, however, is soil moisture and soil type can affect timing of emergence, especially dry conditions that may delay adult emergence by about 2 to 3 weeks. You really need that soil temperature to get warm enough for that pupa to kind of finish pupation and then emerge as an adult. So again, we're using that base temperature, so that lowest temperature threshold of 50 degrees Fahrenheit. For Apple Maggot, the biofix or start date isn't, trap captures. It's more that calendar date of January 1st. Again, this was discovered after a lot of research went into kind of monitoring these insects, monitoring when they emerge, and looking at degree day accumulation. So the adults will initially emerge around 900 degree days from January 1st. So we're getting pretty close here, and sometimes there is once in a while, there will be some early emergence. Again, just really depends on that soil moisture. After this heavy rain, our soil should be quite moist. So definitely not in a dry period anymore, at least. And then from there, so after initial emergence, those first eggs are laid around 1,100 degree days. So 200 degree days later, which translates anywhere from, a week to 2 weeks or so. Peak adult emergence then is around 1400 to 1700 degree days. And then peak egg laying is around 1750 degree days. And usually we see kind of the end of adult emergence around 2800 degree days. So that's usually somewhere in late August, early September. And then they do live for about 30 days. So we can see some egg laying even through harvest for a lot of varieties. So yeah, this is just kind of a snapshot of general estimates for when you might be able to see this emergence in and around your trees and when to consider kind of monitoring for them. So another really great tool if you're kind of like me, I don't know if I want to be doing calculations every day. That can get a little tedious, or everyone is busy and always doesn't have time to do that. So something you could consider is using a really awesome free public tool called the NUA Weather Station Network. This is run through Cornell University. It's just a series of weather stations that has certain sensors to be able to run some of these insect and disease models through. And in Wisconsin, we have about close to 100 weather stations. So it's very, very likely you have one pretty near you, and can use it to kind of auto calculate some of your degree day accumulation if that's something you're interested in. So I took a little screenshot here. So this is at the West Madison Ag Research Station. You can see this, I took this yesterday. We're at 781 degree days, base 50 from January 1st. So getting really close to that 900 degree days where we see initial emergence. And here, if you go on, you can create an account or just kind of go in yourself, and you can put in, if you are catching any apple maggots using traps, you can put in that first trap catch, and then it'll give you kind of a good estimated window of time for when to, if you're spraying, do an application for management, etc. But it's a nice tool just to auto calculate degree days, and could be a good option for folks who maybe don't want to do that calculation every day, which I totally understand. In this slide too, I linked out to the Apple Maggot degree day model. It does go into a little bit more detail about how that model was developed and some factors that it considers. So if interested, definitely check that out when I send this out as a PDF after in the next week or so. So, all right. So we talked a little bit about identification. The IPM triangle is very important to keep in mind for decision making. Reminder, we're trying to limit our chemical inputs if they're not necessary. So then up next, we're going to talk about some cultural and physical control options. So this would be some options you could implement before trying out chemical options. So one option here is to remove nearby host plants and set those traps at nearby abandoned orchards. If you have permission, I think that's a big thing is, being able to talk to that landowner. And if you're really like, man, I haven't gotten fruit in the last several years, and I know it's apple maggot. I wonder if this grower at this landowner at this abandoned orchard would be willing for me to set some traps or whatnot. That could be an option for you. Otherwise, just set those traps, on the side of the tree or on a tree that's kind of nearby those abandoned orchards. That can help you kind of keep track of populations that might be coming over from those orchards. And the goal here is to limit population accumulation nearby. So we're removing those host plants, especially this is a photo of hawthorn, so that we aren't getting kind of populations that are harboring in those areas and coming into your apple trees. You can also consider trap out at nearby abandoned orchards. That would be like mass trapping. I have a few growers who do that, but again, this just an option, definitely a little bit more labor intensive than maybe if you just have a few trees, you'd prefer not to do that, which is extremely understandable. But if you're really hankering for some apples, that might be a good option. Just chat with your local landowner who has that abandoned orchard, ask if you can set some traps, and just see if it helps. So mass trapping, this can be done in your own trees. So the goal here is to trap out large populations attracted to these baited red sphere traps. So what we're trying to do with this is essentially have all of the adult females come to these traps rather than to the apples themselves. So to do this for mass trapping, that is equivalent to about one trap per small tree. So if you have like a dwarfing tree, that would be one trap per tree. 2 to 4 for a medium-sized tree. That would be kind of smaller semi-dwarfing trees, maybe anywhere from 6 to 8 to 10 feet tall. And then using 6 to 8 for a larger tree. So if you have a standard tree or a larger semi-dwarf tree, you'd want to use about 6 to 8 kind of hung at various locations around the tree. Again, we're trying to hang these traps about head height, just so we can reach it easily and identify it. The key with these is you do have to clean them every so often. They just get very buggy and just really crowded pretty easy. What I do if I'm out in an orchard, I just bring paper towels with me and I kind of wipe it off. And then through that Great Lakes IPM link a couple slides ago, you can also purchase, or honestly from your local hardware gardening store, something like Tanglefoot. It's just a sticky substance you can paint on the sphere with a paintbrush, is usually what I use as well. So usually clean those out every so often. And then if you are keeping track of trap captures, just make sure to remove the apple maggots that have been previously captured so you don't double count. Traps should be in place ideally before adult emergence. So like right now would be a great time to set these traps, especially in southern Wisconsin. Otherwise, in the next week or so for areas further north, I think the earlier the better. It doesn't hurt to have them up early. And then those should be remain hanging through early September or around harvest. I already talked a little bit about cleaning traps after checking them. And for initial emergence, I think it's important to check those traps every day, especially with these warm temperatures we've had. Insects are just generally a bit more active when it's warmer. Otherwise, if we hit like a little bit of a cooler spell here in the next few weeks, you may only need to check about once a week. And yeah, so some other cultural and physical control methods. Another option here is placing a barrier under your tree. So the goal with that is we're preventing larvae from reaching the soil to pupate. I have had a few organic growers try this out. This example here, I included some mulch, but they actually used a tarp, which kind of had a dual purpose, right? We're preventing those larvae from dropping to the soil and pupating. They just have that physical barrier between, them dropping from the tree and the soil. And then also it kind of catches all your dropped fruits and they're just a little bit easier to pick up. Which if you were here for the previous 2 webinars, I talked a bit about in each one the importance of sanitation, and I will talk about it again in a few slides. So, and again, our biggest goal with a lot of these practices is to limit chemical input. So in this photo, I included just kind of an example of mulching. Mulching could also be an option. There's also fabric tarp that a lot of folks use for like weed control, but could be an option as well. The thing with mulch is we got to make sure we place it correctly so we're not causing some potential future health concerns for the tree in the future. So when we're placing mulch, ideally it's not mounded up around the trunk. There should be kind of like a little space between the trunk and the mulch itself. And yeah, you can just see the mulch should be about 2 to 3 inches deep. So again, we're preventing that any larvae that are falling either in an apple, maybe they're still inside of that apple, or they emerged and are falling, just down to the soil. We're preventing them from reaching that soil to pupate. Really great option and a pretty cheap option as well. And this, again, will be familiar if you have been on the last couple webinars. Bagging fruit is always an option. Ideally, if you are bagging fruit, you've already started to do that by now. Bagging fruit is kind of a catch-all for a lot of these insects. Usually, bags are put on about 2 weeks or so after petal fall, when those fruitlets start building in size a little bit. Folks further north might still have an opportunity to bag their fruit, as some of they're a little bit further behind in terms of phenology. And in Door County, they were just hitting petal fall last week. So if you're up in Door County area, kind of closer to the lake, or even further north up in the Northwoods, you're probably pretty similar. So anytime after petal fall is great. And again, the goal here is we're preventing insect damage to fruit, and usually implemented after bloom so that things can get pollinated and prior to that insect impact or emergence. This is much more feasible on a smaller scale because we are bagging individual fruit with this method, and that can just get really tedious if you have quite a few trees. And another option could be testing it out on a particular favorite variety or favorite tree. And again, the goal with all of this is to limit chemical input. So some options here for bagging fruit. There's, kind of the three major ones I've seen are using either plastic bags, usually Ziploc bags. Sometimes I'll see people use like grocery bags where they just tie the handle on to around the branch of the tree to protect the fruit. There's also paper bags. Those are a little bit less durable, but could be a good option, especially if folks are wanting to steer a little bit away from plastic. And then there's also some mesh bags. A lot of folks I've seen use frost protection bags. They just have that kind of woven mesh material you can see down here in the left-hand photo. The other thing you'll need with bagging fruit is a securing method. So a lot of times that's just like a twist tie. I've seen people staple things onto a branch, or also using like a string of some sort. You can kind of jerry rig a lot of this and just try things out and see what works for you. And then scissors are important, especially if you're using a plastic bag. If you can imagine, if we're putting an apple in a bag and then maybe it rains, that bag might fill with some fluid or some water, and having that fruit just sit in that water is definitely not good. So my recommendation, if you do want to use plastic bags for bagging fruit, is to use the scissors to cut a little hole at the corner of the bag before you place it, because coming back through and making that cut after you place it just sometimes does not work out too well and is a little bit challenging. So that is my key tip if you do want to try some bagging with plastic bags. So here is a photo from the previous horticulture manager, and he did this with his fruit trees in his yard. These are apple trees. He put about 100 bags on his trees. So I thought this was a really interesting photo, just seeing all these bags in the tree, but he said it worked out pretty well. He got about 80% of this fruit that was, little to no damage from insects and diseases. So could be a really good option if you just want some fruit to make pies or jam or just eat fresh at the end of the season. The key with these bags, or if you are bagging fruit, is to leave them on all summer long, which I know sounds strange, especially if you think about, I don't know, just as apples and fruit grow, but I promise it works and it's for a reason. You'll want to check these bags about every week or so and shortly after storms. I would assume if anyone had bagged their fruit and we had 80-mile-per-hour winds, some of those bags might not hang on. So there may be some reapplying or putting on bags that might be necessary. And paper bags just might need to be replaced after a heavy rainfall or storm. The key with this is to remove those bags about 2 to 3 weeks before harvest. That's just so that fruit can kind of color up a little bit more before we actually pick it. And usually by that point, we're kind of past a lot of the major concerns for insects, especially. All right. Like I promised earlier, I talk a little bit about sanitation. Sanitation just means we're going through and picking up any drop fruit, ideally weekly through the summer, because again, sometimes fruit that are infested with either plum curculio, codling moth, or apple maggot might actually fall to the ground. And if you can imagine, that insect just has a lot better chance of survival. They're not dropping from the tree. They don't have to avoid predators as much. So they're right on the soil itself and just really easy for them to emerge, bury into the soil and pupate. So ideally, we're removing that fruit about weekly, any that have fallen. Again, with the goal of preventing the apple maggot life cycle completion. All right, so those were all kind of methods that we want to consider before using chemicals, right? And if you were here for the coddling moth talk, I talked a little bit about a biological control method using coddling moth virus. Apple maggot doesn't quite have anything like that developed yet. Hopefully, could be in the future, but still a lot of research to do. So for biological control, that's really just promoting habitat for natural enemies. So, as that larvae exits the fruit to pupate, that's kind of when they're most susceptible to being predated. And there are a lot of different natural enemies out there that feed on apple maggot, including some parasitoids. There's a couple wasps, not super effective, but they exist. Birds, spiders, carabid beetles, ants. These don't have a huge impact on populations, but it does help a little bit. And then I included this photo on the left-hand side here. This is kind of what this product, it's not a biological, it's a organic product called Surround, which is using kaolin clay, which essentially just coats the leaves and the fruit and doesn't taste or smell very good to a lot of insects. So I included this because Surround is really the least harmful to a lot of these natural enemies, and does a pretty good job of keeping pests at bay. So this could be a really great option, especially if we want to consider protecting our natural enemies. All right, jumping into chemical control, again, I want to just highlight that action threshold is 5 flies per trap with a baited red sphere trap, or 1 fly per trap with an unbaited red sphere trap. So once we hit that threshold, that's kind of, and you've tried maybe a lot of these cultural or physical control methods that aren't super working out too well for you, you might want to consider using a chemical control option. So the bolded ones here, kaolin clay, pyrethrin, spinosad, these are just kind of product names that you might see at your local garden store, hardware store, etc. These are all organic approved and would be probably my recommendation for home growers. Some of these other products, these are what we call conventional products, and they're a little bit more intense and do have a lot of impact on other non-target insects as well. So I usually don't recommend any of these products unless, it's a commercial grower who's selling that fruit, or if it's really, really, really impactful and has been a huge issue. So yeah, there's some products here. I included a couple screenshots here of these 2 production guides that dive a lot deeper into chemical control methods and non-chemical control methods for a lot of different insects. So this one up here is called the Midwest Fruit Pest Management Guide, was just updated this year. goes through a lot of kind of what I talked about today and in previous webinars about these insects, giving background information, best management practices, etc. And Cornell has a really great guide to organic apples as well that can be great. Few disclaimers, and then I think next slide will be questions. Always read and follow pesticide labels if you do end up using a pesticide, because it is the law. So just make sure to review that. I know they're long, I know they're boring, but it is very important so that you know how to keep yourself safe and how to keep your the other animals and other insects in your yard safe. If you are making back-to-back applications, so you do have a really, really heavy population, you can do a second application after that first one about 10 to 14 days later. So that would just be kind of knocking everything back a good ways. And again, we have that continued emergence. So sometimes it takes a few applications to actually see an impact. Key here is do not apply insecticides during bloom. Most of us should be past that by now, but most pesticide labels will have a bee advisory box that indicates, it might be impactful to pollinators. You can always reference the latest Midwest Fruit Pest Management Guide for the most up-to-date recommendations and some more in-depth information. And then just keep in mind that sometimes recommendations, application rates, and usage practices might change. You can always, always, always reach out to myself or your local extension professional for the most current information. So really just wanted to add those disclaimers before we jump into some resources and questions. And looks like we have just a couple of minutes left. So I'm going to go check and see if we have any Q&A. No questions. So if you do have a question, feel free. I think at this point, if it's easier for you to throw them in the chat, please do so. Otherwise, that Q&A, definitely feel free to throw that in there. I threw a lot at you today, and I know it helps for me to review. So just keep in mind, this is recorded and will be posted on our YouTube channel. I'd also like to point you to this Apple Maggot fact sheet. Again, I will send this all out to everyone who registered in about a week or two. So this Apple Maggot fact sheet will include a lot of the information that I talked about today. And then on our horticulture website, we just have kind of a list of a lot of fact sheets, resources for, apples, for fruit, but also for vegetables and just general gardening practices. So really great resource. I included a bunch more here that you might consider using or looking into. So, all right, we have about 3 minutes left. Waiting to see if there are any questions. Don't see any quite yet. But that is okay. So we have one question here. What's the impact of soil type on pupating maggots? So soil type, it has a lot to do with how it retains moisture. So some soil types retain moisture a lot better, while others, maybe it drains a little bit easier. So how coarse it is a big thing. And then also it has a lot to do with if it holds heat well. So some soils hold heat a little bit better than others. And like I've said a few times here, it's really, temperature is really, really important for insect development. And they need, at least 50 degrees or higher for them to continue development. So hopefully that answered your question, Eric. Thanks for the question. We got about 2 minutes left. Happy to answer questions. Otherwise, if folks do have questions, they can always use that Ask a Gardening question. And again, this will be posted on our YouTube channel for review. All right, not seeing any more questions come in. And we're about 1 minute to 1 o'clock. So I just want to thank you all for joining today. This has been a really, really fun series to do. I am a big bug nerd, so definitely had a great time and hope you learned something along the way. And like I said in the very beginning, I'll be sending out an evaluation and would love to hear some feedback or some recommendations or ideas you are interested in for future presentations or workshops. And with that, yeah, thank you all for joining, and I hope you have a great rest of your Friday. Hopefully you can get outside. It's absolutely beautiful out, and hope you all take care.